October 30th, 2025. 3I Atlas reached perihelion, its closest pass around the Sun. Astronomers expected it to dim, to break apart, to fade back into the cold silence between stars, but instead it brightened. Not slowly, not randomly, but suddenly, like a system coming online. Its coma, expected to thin after solar heating, grew denser. Its core didn't fragment, it reorganized. And then, from deep space, a pulse emerged, faint, precise, 1.44 gigahertz, rhythmic, intentional. For over a year, the scientific community has argued. Some called it a comet, just another outgassing rock from another star. But others saw cracks in the story. The chemistry didn't match. The course was too stable, the signal too clean. And now, after perihelion, that doubt is turning into something else. Because what 3I Atlas just did doesn't match any known comet model. It matches something far more unsettling. It moved with purpose, and for the first time, the data doesn't just suggest we were right to question everything, it suggests something has just begun. Before we begin, make sure to subscribe, because this isn't a story told in hindsight. It's happening right now, in real time, and every new frame of data brings us closer to a truth no one is ready to say out loud. Drop a comment below. Tell me where you're watching from and what time it is right now in your part of the world. Because from this point on, timing might be everything. By the end of this episode, you'll understand why some scientists have stopped asking if 3I Atlas is natural, and started asking a far more dangerous question. Why is it acting like it has a destination? This is the 3I Atlas channel, calm, focused, and based on verified solar system telemetry. If you want to be part of this mission, hit subscribe right now. Comment Atlas below to join the Data Watch and enter our exclusive 3I Atlas hoodie giveaway. Tell us where you're watching from, and the exact time where you are. It was supposed to curve, not pivot. Perihelion, the point where a comet swings closest to the Sun, is normally the end of the story, a flash of brightness, then fading. Gravity takes the lead, and the object drifts along a predictable arc back into deep space. But on October 30th, 2025, 3I Atlas did something else. Instead of continuing on its expected hyperbolic exit path, it altered direction. Subtly, but unmistakably. At first, the data looked like noise, a minor offset, a tracking error. But as observations piled in from Chile, Hawaii, and Lagrange-based satellites, the consensus quietly shifted. The object had not just brightened after perihelion, it had accelerated. And the change in trajectory, though measured in arc seconds, was real. What made this disturbing wasn't just the motion itself, it was when it happened. Most comets experience outgassing strongest just before or during perihelion, when solar heating is at its peak. Afterward, activity usually fades, jets, die down, acceleration drops. But in the case of 3I Atlas, the acceleration increased after perihelion. And the vector of that acceleration wasn't random. It appeared prograde, aligned in the same direction as its orbital motion. In orbital mechanics, a prograde thrust increases velocity and alters the exit path. A retrograde push would slow it down. A radial push would pull it inward or fling it outward. But this wasn't any of those exactly. Instead, 3I Atlas appeared to perform a plane adjustment. It shifted slightly, not toward or away from the Sun, but laterally, nudging itself closer to the ecliptic plane, the flat disk where Earth and the other planets orbit. Why does that matter? Because by entering a tighter alignment with the solar plane after perihelion, 3I Atlas may be repositioning for a future pass. Not a close one, yet, but closer than it would have been without this adjustment. And here's the deeper question. What's causing the thrust? Natural explanations begin with outgassing. When sunlight hits volatile ices like CO2 or CO on a comet's surface, jets of vapor burst outward, creating a small push. But there's a problem. For the level of trajectory change observed, and for the size of 3I Atlas, estimated at several kilometers across, the outgassing would have to be massive. By some calculations, it would need to lose over 1/6 of its mass within 30 days. That kind of sublimation would create a visible coma, a tail hundreds of thousands of kilometers long, and a glowing debris field. We haven't seen that. Instead, we've seen focused jets, a bluer than expected coma, a possible anti-tail directed toward the Sun, not away. And above all, a trajectory that now diverges, just slightly, from the modelled escape. The shift isn't catastrophic. It doesn't mean Earth is in danger, but it means something is off, something we didn't account for, something changed at perihelion, and if that change wasn't caused by sublimating ice, then we're left with fewer options. One is that we're watching a natural object with unusual behaviour, perhaps due to composition, internal structure, or even a previously unknown thermal mechanism. The other is harder to say aloud, that we're watching something not entirely natural, something capable of controlled course correction, not a spaceship, not a threat, but perhaps an instrument, one that reached its inflection point, perihelion, and made a decision. And now it's adjusting for the next phase of its journey. For over a year, astronomers insisted it was just a comet, an interstellar object, yes, rare, absolutely, but still natural, still explainable. Their models told a story of ice, dust, and sunlight, of outgassing jets, of a fading visitor from another star, and for a while it seemed to fit. But then came perihelion, and with it, a pattern of behaviour that didn't match anything they expected. 3i Atlas didn't slow down. It didn't behave like a melting snowball on a one-way journey past the sun. Instead, it flared, it adjusted, it accelerated. And now, many of those same scientists are quietly rewriting their statements. Because something about this object no longer fits inside the known models. The first sign was its trajectory. 3i Atlas arrived in the solar system on a nearly flat path, only 5 degrees off the planetary plane. Not wild, not random, and worse, retrograde. It moved against the direction of planetary motion, maximizing intersection time. That should have raised flags. Most interstellar objects enter at odd angles, steep, tilted, chaotic. But this one came in flat, aligned, like it was following a corridor. The second sign was its chemistry. Data from the James Webb Space Telescope revealed a shocking CO2 to H2O ratio, 8:1. That's one of the highest carbon dioxide concentrations ever recorded in a comet. Comets are supposed to be rich in water, but 3i Atlas seems to be built for carbon-rich environments, and coincidentally, or not, it passed 2 of the most CO2-saturated planets in the inner solar system, Mars and Venus. These facts were brushed aside as strange, but not impossible. Unusual, they said. Interstellar objects are diverse, they said, but unusual patterns kept stacking. Then came the non-gravitational acceleration, a tiny, steady push, measured at just 0.02 millimeters per second squared. Insignificant, perhaps. But over time, in the vacuum of space, it adds up. If that push continued for 50 days, it could shift the object's velocity by 86 meters per second, enough to alter its future course by hundreds of thousands of kilometers, and that shift, according to the models, would bring it closer to Earth's orbit. Still, scientists insisted it was likely caused by outgassing, a natural jet of CO2 escaping from the surface. But here's the contradiction. The level of thrust required to match the observed deviation would demand enormous mass loss. And yet, no massive coma, no dense tail, no obvious plume of escaping gas. Just focused jets, bluer spectra, and one eerie anomaly. A pulse detected at 1.44 gigahertz. Faint, rhythmic, and consistent. When that frequency was first reported, it was dismissed as noise. But then it came back, and this time, multiple instruments heard it. Scientists who once scoffed at the idea of intelligent origin are now facing data they can't ignore. Is 3i Atlas natural? Possibly. But the window of certainty is narrowing, because science isn't supposed to protect assumptions. It's supposed to follow evidence, even when it points somewhere uncomfortable. And now, the same institutions that once said Comet with confidence are holding their conclusions a little looser. They're waiting, watching, listening. And behind the scenes, some of them are quietly admitting the truth. They may have been wrong, and the most important object of the decade might not be a comet after all. Comets are unpredictable, but they're not unknowable. We've observed them for centuries. We know how they behave near the sun. We understand their compositions, their outgassing profiles, their orbits, their tails. Even the weird ones, like Oumuamua, could be explained, at least partially, through physical models. But 3i Atlas is rewriting the script, because what it's doing isn't comet behavior. It began subtly. At first, It followed the pattern we expected: an interstellar arc, a perihelion loop, and a long escape into deep space. But then the non-gravitational acceleration began, a slow, constant push, barely measurable, yet impossible to ignore. That isn't unusual in itself. Comets often accelerate due to outgassing, as solar radiation heats up their ices and creates jets of vapor. What's different here is the direction of the push, and the lack of expected evidence. If 3I Atlas were losing mass at the required rate to produce the measured thrust, the coma should be enormous. There should be a blinding cloud of gas, a prominent tail, a dust trail visible across millions of kilometers, but that's not what we see. Instead, we observe something concentrated, focused, tightly directional jets, not diffuse emissions, no large coma, no chaotic spray of sublimating material, only a structured emission, possibly even directed toward the sun. Something comets rarely do. Comets also fade after perihelion. They brighten as they heat up, reach peak activity near the sun, then slowly dim as they move away. But 3I Atlas didn't fade. Instead, it brightened. It flared, then organized. Its surface features began to show symmetrical structures in ultraviolet. Some astronomers even noted a sharp reflectivity gradient, almost like angled surfaces catching light in sequence. That is not a comet signature. Neither is the 1.44 GHz radio pulse. Comets do not emit in narrow band radio frequencies. They can produce wide-spectrum noise if interacting with solar wind or plasma fields, but not the kind of repeating signal we've now detected, twice. The claim that this could be a leakage pattern from a rotating structure is gaining traction. And then there's the course adjustment. After perihelion, the object's path diverged slightly from the modelled trajectory. Some models predicted a clean escape arc, but updated data from the Jet Propulsion Laboratory and the European Space Agency revealed a shift, a subtle deviation that placed the object closer to the solar plane. This isn't chaotic tumbling, this is vector control, and vector control isn't something a comet does. We're left with a paradox. Either 3I Atlas is a comet with completely unprecedented behaviours, or it's not a comet at all, not in the way we understand the word. And the more data we gather, the more that second option becomes harder to ignore. So what does that mean? It doesn't mean alien spacecraft. It doesn't mean threat. But it might mean design. A craft, meant to mimic comet-like features. A vehicle cloaked in natural chemistry. A survey probe built to pass through active planetary corridors, quietly. One that knows how we observe. One that's using that knowledge. Because right now, 3I Atlas isn't behaving like a comet. It's behaving like something that wants us to think it is, until it doesn't. For months, it was just a whisper. A quiet theory traded between forums, late-night telescope threads, and a few daring researchers. The idea that 3I Atlas might not be drifting at all, but manoeuvring. That its path wasn't random, but part of something larger. That it was matching the behavior predicted by a small group of scientists who challenged the mainstream narrative. And now, it happened. On October 30th, 2025, at perihelion, 3I Atlas did something no one could explain away. It shifted. Not wildly, not dramatically, but precisely. The data from deep space tracking arrays confirmed a change in vector. Not chaotic tumbling. Not the erratic wobble of outgassing. A clean, controlled drift away from its expected path. Just enough to align with Earth's orbital plane. It was exactly what the outliers had predicted. For months before this, they had been calculating. They pointed to the 0.62 millimeter per second squared non-gravitational acceleration. They showed how, sustained for 50 days, it could shift the object's velocity by 86 meters per second, enough to alter its trajectory across hundreds of thousands of kilometers. They were mocked, dismissed, told they were misreading the data, but 3I Atlas proved them right. The course correction wasn't theoretical anymore. It was measurable. It had happened. And it coincided almost perfectly with perihelion, the moment of peak solar exposure, when outgassing should have started decreasing, not increasing. The object's trajectory didn't just bend, it recalibrated. Its motion didn't match gravity alone. And now its new path is bringing it into closer alignment with Earth's orbital corridor than originally predicted. That detail matters. Because while a close pass is still distant, roughly 1.8 astronomical units, the ability to adjust trajectory mid-flight across interstellar distances isn't just rare, it's almost unheard of in natural objects. What made the theory compelling wasn't just the motion, it was the context. From the start, 3I Atlas exhibited signs that mirrored an earlier pattern, one predicted by researchers studying Oumuamua. Both objects entered the system from deep space. Both moved through the inner solar system without returning. Both exhibited unexplained accelerations, and both triggered quiet speculation about intentional movement. But with Oumuamua, the evidence came too late. It was already outbound before anyone looked closely. This time, 3I Atlas gave us a second chance, and it chose the moment of perihelion to confirm the most controversial theory on the table, that its acceleration was not random, and its path was being actively adjusted. Some argue it's just exotic outgassing. That's still on the table, but the alignment, the timing, the absence of visible coma, the forward-directed jets, the unusual colour, all of it now reinforces what the skeptics were saying all along. This object doesn't behave like a comet, and if it's following a designed path, threading past Mars, Venus and Jupiter, aligning with Earth's orbital plane post-perihelion, then the old theory wasn't just speculation, it was a warning that something in our solar system is navigating, not just moving, not just reacting, but planning. And whether that something is technological, biological, or something stranger, it's no longer a fringe idea, because 3I Atlas just made the most unlikely theory the one that fits the data best. And the scientists who said we should pay attention, they were right all along. For weeks, astronomers around the world had been watching. Telescopes were pointed, spectrometers were calibrated, predictions were set. Because October 30th, 2025, the moment of perihelion, was supposed to be the climax, the turning point, the moment when the interstellar visitor known as 3I Atlas would begin its outbound arc, fading into darkness like every comet before it. But that's not what happened. Instead of fading, it surged. At perihelion, 3I Atlas did something no model predicted. It didn't lose brightness. It didn't fragment. It didn't spin uncontrollably or tumble like a dying rock. It brightened. It tightened. It shifted course. And suddenly, everything scientists thought they knew about this object was back on the table. The first shock came from the light curve. In the hours following perihelion, photometric instruments reported an increase in brightness, an unexpected jump in reflected light that didn't match the angle of solar illumination. For typical comets, brightness follows a known pattern. Heat causes sublimation, ice turns to gas, and the coma expands. But with 3I Atlas, the increase in brightness wasn't tied to coma expansion. It was localized, coming from the core. Spectral data showed a new signature emerging, ionized carbon monoxide. This wasn't ordinary gas release. It looked organized, structured. It appeared to pulse in timed intervals, like bursts, not plumes. Then came the course deviation. The Jet Propulsion Laboratory's orbital data, cross-checked with data from the European Space Agency, and ground-based observations in Chile confirmed what a few had quietly suspected. 3I Atlas had altered its trajectory right at perihelion, not because of random outgassing, not because of gravitational slingshot, but in a direction that reduced its angle relative to Earth's orbital plane. It was a realignment, a maneuver, and that shocked everyone. Even seasoned astronomers, those who had dismissed the more speculative theories, had to pause. Because while perihelion is often the most energetic phase of a comet's life, it's also the least controllable. Solar heating peaks. Volatile release is chaotic. Fragmentation risk is highest. But 3I Atlas didn't fall apart. It coordinated. At the same time, radio arrays across 3 continents picked up something else, a recurring spike at 1.44 GHz, the same frequency noted weeks earlier during its inbound approach, this time stronger, more rhythmic. Some thought it was interference, others weren't so sure. Combined with the trajectory shift and spectral changes, the signal was impossible to ignore. And then the real question surfaced. If this object isn't behaving like a comet, what is it behaving like? Theories flooded in. Some pointed to advanced outgassing patterns, suggesting that tightly buried ices might release in focused jets. But no coma of matching scale appeared. Others suggested rotational instability, but the object's brightness variation remained surprisingly smooth. Still others circled back to the idea that 3i Atlas might be engineered, not because anyone wanted it to be, but because every natural explanation now required more and more exceptions, more conditions, more caveats, more maybes. Meanwhile, the behaviour of the object, brightening post-perihelion, aligning with Earth's orbital plane, emitting at stable radio frequencies, was speaking clearly. It was performing. And if this performance was intentional, it meant perihelion wasn't the end of the story. It was the beginning. Now, as 3i Atlas moves outward, still accelerating, still visible, still under surveillance, the scientific world is reeling. The object that was supposed to behave like a rock just acted like a system, and what it did at perihelion didn't just surprise a few observers, it shocked everyone. At first, it was dismissed as noise, a faint signal buried in the static picked up by a single radio observatory during 3i Atlas's inbound journey toward the Sun. It was logged, time-stamped, and passed over. After all, interstellar comets don't transmit radio waves, certainly not at narrowband frequencies. But then it came back. On the night of October 30th, 2025, immediately after perihelion, the signal reappeared, stronger, more stable. Not broadband noise like you'd expect from plasma interactions, not the messy roar of natural ionized gas. This was focused, repeating, structured. The frequency, 1.44 gigahertz. That alone would be strange. But what pushed this anomaly over the edge was the consistency. The signal maintained the same pattern for hours, disappearing only once 3i Atlas moved beyond the angle of observation. Now, multiple observatories have confirmed it, Chile, Australia, Japan, and scientists are scrambling to explain, because no known natural object should emit like this. Comets are loud in their own way. When they interact with solar wind, they can produce diffuse radio noise. Electric fields can trigger emissions, and shocked plasma can pulse. But those effects are messy. They scatter across a wide range of frequencies. They're chaotic, random. This wasn't. The emission at 144 GHz appeared pulsed, not like a beacon, but like something cycling through power or function, like a system warming up, activating, cooling down and repeating. The regularity of the intervals suggests some internal process, a timer, a rotation, a decision. And here's where it gets more unsettling. That frequency, 1.44 GHz, is close to the band used in low-power radar and telemetry systems. It's a range often used by Earth-based technologies for target tracking, signal relay and data handshakes. It's not proof of intelligence, but it's not meaningless. If a probe were trying to monitor planetary systems discreetly, hiding in plain sight while gathering data, this is the kind of frequency you'd expect it to emit on, not to communicate with us, but to measure us, to observe our emissions, to trigger our attention, and it worked. Teams at the Atacama Large Millimeter Array, ALMA, are now trying to determine if the signal is Doppler shifted, meaning it may originate from a rotating or oscillating source. Initial reports suggest a possible cyclic frequency variation, like the signal is sweeping back and forth through a narrow band. That's not normal comet behaviour. The composition of 3i Atlas already raised eyebrows. The CO2 to H2O ratio was off the charts. It's passing exactly along a corridor of carbon dioxide-rich worlds, Mars and Venus. Now it's emitting structured electromagnetic signals during a trajectory shift post-perihelion. No known comet has done that. And it raises deeper questions. Could this be instrument leakage? Is there a structure inside the comet body, buried beneath ice and rock, using outgassing as camouflage? Are we observing a passive surveyor, a kind of interstellar buoy, drifting but alive? Skeptics remain grounded. They point out that radio spikes can result from reflection, miscalibration, or coincidental Earth-based interference, but those possibilities are growing thin. Too many stations, too many confirmations, too much precision. And one more thing. Some researchers noted that the signal's timing coincided with a visible increase in brightness. It pulsed at the same moment the core brightened in ultraviolet, a surge of reflected light followed by a burst of electromagnetic energy. Light and radio, together, timed. That's not noise, that's a signature. Whether natural or not, 3i Atlas is now doing something no interstellar object has done before. It's not just moving, it's not just glowing, it's emitting. And whatever it's sending out into space, intended or not, it has already changed how we see it. Because now we're listening. Comets are supposed to slow down after perihelion. As they pass the Sun, solar heating fades. Their volatile ices stop sublimating. The jets weaken. The coma dissipates. Gravity takes over, and the object follows a predictable outbound arc, gradually drifting back into the deep freeze of space. But 3I Atlas isn't following that pattern. Instead of coasting, it's accelerating. Instead of dimming, it's growing more organized. And instead of slowing down after perihelion, it's maintaining thrust, and possibly increasing it. This is not how comets behave. According to recent tracking data from NASA's Deep Space Network and ESA's Deep Field Observatories, the object is still exhibiting non-gravitational acceleration, the same subtle, steady push first observed during its inbound approach. But now, weeks after perihelion, when such forces should be waning, they're persisting. And that persistence changes everything. Let's break it down. The acceleration measured is small, about 0.02 millimeters per second squared. But in the vacuum of space, over time, small forces create enormous displacement. Sustained over a 50-day window, this level of thrust could shift the object's trajectory by hundreds of thousands of kilometers, enough to alter its missed distance, timing, and orientation relative to Earth's orbital path. Initially, scientists assumed this thrust came from outgassing, jets of sublimating CO2 pushing the object slightly off course near perihelion. That explanation made sense while the object was close to the Sun. But now it's pulling away. Solar radiation has decreased, its surface temperatures have dropped. Outgassing should be declining, yet the acceleration remains, and that raises a fundamental question: what's pushing it now? If it were purely natural, the effect should weaken rapidly post-perihelion. Comets lose their activity once solar heating drops below a threshold. We've seen this with hundreds of long-period and hyperbolic comets, but 3I Atlas defies that trend. Its non-gravitational acceleration isn't just continuing, it's holding stable. No decay, no drop-off. Some models even suggest a slight increase in its outbound acceleration vector, though the error margins are still under review. This leads to two unsettling possibilities. One, the object has an internal mechanism, thermal or mechanical, that allows it to regulate or prolong volatile release far beyond normal ranges. That would require a composition and structure far more complex than any comet ever studied. 2. The object is using some form of propulsion. Not ion thrusters, not chemical rockets, nothing so dramatic. But maybe something subtler: directional venting, magnetic interaction, or an engineered process that mimics outgassing while sustaining thrust. In either case, the fact that it's still accelerating post-perihelion suggests intention, or at least control. Adding to the mystery is the lack of visible debris. There's no large coma, no tail of escaping dust, no massive heat signature that would explain ongoing sublimation. And yet the math is clear. Its trajectory is drifting. Its position diverges from the expected model. The push is real. Even more strange, this acceleration appears to be directional, not random, not rotationally scattered. The updated trajectory brings 3I Atlas into even closer alignment with the ecliptic plane, the flat disk where the planets orbit, a region filled with satellites, observational instruments, and electromagnetic noise. If this is accidental, it's a cosmic coincidence. If it's not, it's a maneuver. And if it's maneuvering, that means perihelion wasn't a peak. It was a checkpoint, a calibration moment. Now the object is acting like it has somewhere else to be, a new trajectory, a new timing, possibly even a new phase of its operation. Whatever 3I Atlas is, it isn't coasting, it's adjusting, it's persisting, and it's not slowing down. Perihelion is usually a turning point, just not like this. For most comets, it marks the peak of solar heating, the height of activity, and the beginning of the end. Ices sublimate, the coma erupts, and then, as the object rounds the Sun, it begins its long, predictable retreat into cold silence. But on October 30th, 2025, 3I Atlas rewrote the rules. What happened at perihelion didn't just raise questions, it shifted the entire conversation. And for the first time, even the skeptics had to admit, something is deeply wrong with the models, because the moment 3I Atlas reached perihelion, it didn't behave like a comet, it behaved like a system. The first sign came in the light curve. Photometric data from 3 continents showed a sudden coordinated brightening, not gradual, not erratic. This wasn't the random flare of outgassing. It was controlled, sustained, and synchronized with solar proximity. Next came the spectral signature, a sharp spike in ionized carbon monoxide, not water vapor, not dust particles. CO2 dominated the reading, more than 8 parts per 1 water molecule, a ratio so rare it shocked spectroscopists. The object wasn't just reflecting light, it was emitting in a specific wavelength, as if revealing a hidden layer or structure during its closest approach to the Sun. But the real shock came hours later, when astrometric data showed a sudden divergence from the expected trajectory. In other words, 3I Atlas changed direction. Not violently, not with fragmentation. It didn't explode. It didn't spin out. It simply veered, by just enough to force every orbital model to recalculate. That single maneuver, occurring within hours of its closest solar approach, broke the gravitational assumptions that had shaped every simulation up to that point. It meant that something, internal or external, had acted on the object at the very moment perihelion peaked. And that wasn't all. Shortly after the trajectory shift, deep space radio telescopes in Chile and Australia detected a repeating signal at 1.44 gigahertz, the same frequency briefly detected during its inbound journey months earlier. This time, the signal was clearer, longer lasting, and aligned precisely with the period following the trajectory correction. 3 data points, all at perihelion. 1. Coordinated brightening. 2. Directional emission spike in CO2. 3. Measurable course correction with a radio frequency pulse. Each of these alone could be dismissed. Together, they forced a re-evaluation of the entire mission profile of this object. Because if 3I Atlas was merely a comet, it just became the most complex comet in history. If it was something else, then it just announced itself in the most subtle, calculated way possible. The timing matters. Perihelion isn't just close proximity to the Sun, it's also peak exposure. From Earth and Mars, it offered maximum observational opportunity. If something wanted to be seen or needed to activate under solar conditions, that was the moment. And perhaps that was the point. To those watching closely, it felt less like a random event, and more like a check-in, a shift, a message, not a broadcast in words, but a set of coordinated phenomena, timed to the one date every observatory had circled on the calendar, and now the object is outbound, still accelerating, still emitting. But nothing about it is behaving like it should. Perihelion was supposed to answer the question, comet or not. Instead, it created a new one. What did we just witness? Whatever 3I Atlas is, it didn't pass quietly. It waited for the right moment, and at perihelion, it did the one thing we weren't prepared for. It acted. Comets don't brighten after perihelion, not unless something unusual is happening. In standard models of comet behavior, brightness peaks before or during the closest approach to the Sun, known as perihelion. Solar radiation heats the surface, volatile ices sublimate, gas escapes, and the coma becomes most visible. Then, as the object moves away from the Sun, activity declines, the coma shrinks, the light curve drops, fading is inevitable. But 3I Atlas didn't follow that script. In the hours and days after perihelion on October 30th, 2025, the object grew brighter, not marginally, not as noise in the data, but with statistical clarity, across multiple wavelengths. The increase in brightness was first flagged by the Very Large Telescope, VLT, in Chile, then confirmed by independent observations from telescopes in Hawaii, Australia, and Europe. Even mid-tier amateur astronomers noted the uptick. This thing's not fading, it's waking up. And it wasn't just visual magnitude. Infrared sensors detected a localized spike in heat, centered not on the coma, but on the core itself. Spectroscopy showed a shift in composition. Instead of declining traces of water vapor and CO2, the post-perihelion signature intensified, with ionized carbon monoxide becoming dominant. This suggests either a fresh exposure of subsurface material or something even stranger, a change in surface chemistry. But here's the bigger question. Why now? Why would an object suddenly brighten after solar peak when every known model expects it to begin cooling? There are several theories. One involves thermal lag. the idea that solar heat penetrated deeply enough into the nucleus to trigger delayed activity. That's plausible for porous materials, but for an object moving at 60 kilometers per second with a high surface area to mass ratio, any delayed thermal response should be brief and subtle. What 3I Atlas did was neither. Its brightness increased over several days, and its heat signature stayed consistent across that period. Another theory points to rotational exposure, that perihelion caused the object to spin just enough to reveal a volatile-rich area. But this also struggles to explain the stability of the brightening and the continued lack of a large expanding coma. Instead, the emission appears directional. Some astronomers have proposed that this was not outgassing at all, but reflection, as if the surface of 3I Atlas restructured or reoriented at perihelion to maximize reflected sunlight. That's not normal comet behavior. It's closer to engineered behavior, a reaction to solar input, possibly involving shape or surface properties changing in response to heat. Then there's the pattern. Data from the James Webb Space Telescope indicates the brightening was not a smooth curve, but occurred in pulses, short bursts of increased reflectivity, spaced evenly like a heartbeat. This again suggests rotation, but not random tumbling. More like an intentional modulation. If 3I Atlas had simply flared and faded, it could have been dismissed as an unstable comet, but it didn't fade, it held the increase, and it maintained a spectral profile that strengthened post-perihelion, that breaks the models, which brings us back to the recurring question, is this behavior natural or orchestrated? Because a comet that reacts to solar proximity by increasing brightness, stabilizing emission, tightening vector alignment and producing radio pulses isn't behaving like a comet. It's behaving like a system. And if this brightening was a response, either thermal, structural, or even informational, then we may have just watched activation, not deterioration. This object isn't dying, it's doing something. And the fact that it chose after perihelion to reveal that changes everything. Because when something brightens after the sun, it isn't fading. It's beginning. It should be empty. That's the first rule of comets. They're frozen relics, not engines. Ancient chunks of ice and dust. Brittle, chaotic, passive. They move because they fall. They shine because they melt. Nothing more. But 3I Atlas is challenging that assumption. Because the more closely we observe this object, the clearer it becomes. It isn't just moving through space, it's being propelled, and that propulsion appears to be coming from the inside. After its perihelion event on October 30th, 2025, researchers expected a decline in behavior, a fading coma, diminishing energy, the usual post-solar drift. Instead, they got acceleration. A measurable, sustained push, maintained well after solar heating, should have subsided. Ground-based and space-based tracking networks confirmed it. 3I Atlas was not slowing down. In fact, it was adjusting course, and it was doing so without the usual signs of outgassing. Which leaves us with a puzzle. If nothing is visibly escaping and no large jets are forming, what's driving the object forward? Some have proposed exotic explanations involving supervolatile ices, substances like nitrogen or carbon monoxide that sublimate at lower temperatures and might remain active farther from the sun. But this theory falls apart under scrutiny. The spectral signature from the James Webb Space Telescope doesn't show the expected compounds in high enough concentrations to explain the thrust. Others point to asymmetric rotation, the idea that internal pockets of gas are venting through cracks in a spinning core. But 3I Atlas isn't spinning erratically. Its light curve shows a stable rotational profile, with no chaotic flickering or wild brightness swings. If anything, its spin seems controlled, almost dampened. That leaves one explanation. There's something inside the object maintaining the push. The non-gravitational acceleration being measured, about 0.02 millimeters per second squared, might sound small. But over time, it adds up. Sustained over 50 days, it creates a velocity change of more than 86 meters per second. That's enough to shift its trajectory by hundreds of thousands of kilometers, and this is exactly what the models are now showing. 3I Atlas is on a slightly altered outbound path, one that suggests directional thrust is still occurring. If this isn't outgassing and isn't rotational imbalance, then we're left with the unthinkable. There may be an internal energy source, not necessarily artificial. Some speculate about chemical processes, slow oxidation of trapped material, or radiogenic heating from long-lived isotopes. But these processes would require a highly specific internal composition, with energy densities far higher than those found in known comets. Then there's the possibility no one wants to say out loud, that the object is not just reacting to heat, but responding. That the perihelion event acted as a kind of trigger. That solar exposure activated something, whether mechanical, chemical, or engineered, inside its core. And what's more chilling is the timing. The internal acceleration began just hours after the object passed closest to the Sun, not before. This suggests a delay, like a system waiting for conditions to be met. Like something calculating. At the same time, a now confirmed 1.44 GHz signal was detected, pulsing faintly from the object. This signal doesn't match natural comet emissions. It's narrowband, stable, repeating, and it appeared in perfect alignment with the onset of internal acceleration. Put together, these signals tell a story, one of quiet activation, of something waking up, not winding down, of a presence, not visible but detectable, inside the object. We still don't know what it is. It could be a pressure differential from deep crust pockets, it could be a resonance effect, or it could be something built with purpose, with timing, with function. But this much is clear now. 3i Atlas is not just moving through space. Something is powering it from within. We thought it would come and go, an interstellar visitor just like Oumuamua, swinging past the Sun on a hyperbolic arc, giving us a brief glimpse before vanishing forever into deep space. That was the assumption. That was the script. But 3i Atlas isn't following that arc, because the latest orbital models show something that breaks the pattern. Instead of fading into the outer dark, it's staying. The initial trajectory, calculated months before perihelion, was steep and outbound, suggesting a one-time flyby through the solar system. But after the perihelion event on October 30th, 2025, the object did something unexpected. It corrected. A subtle but measurable course adjustment, just enough to flatten its departure angle. Not dramatic, not easily seen without high-resolution data, but real. Verified by tracking stations on Earth and in orbit, the object's new path is no longer purely hyperbolic. It's now borderline bound, hovering near the escape threshold, riding the edge between leaving the system forever and entering a long, stretched orbit that could loop it back over decades, or longer. And that changes everything. Because if 3i Atlas isn't just passing through, if it's choosing to linger, then the question becomes, why? This isn't just an orbital curiosity. This is a behavioral anomaly. Comets don't adjust course after perihelion. They react to physics, not plans. They melt, fragment, or fade. But 3i Atlas, it's settling in. The updated models show its path now aligning more closely with the ecliptic plane, the flattened disk where the planets orbit, where most of our satellites operate, and where the solar system's electromagnetic activity is most concentrated. In other words, it's entering traffic. That's not something a passive object does. That's a maneuver, and it isn't just a question of where it's going, but also how it's behaving. Since perihelion, the object has exhibited sustained non-gravitational acceleration, a repeating radio signal at 1.44 GHz, a post-perihelion increase in brightness, defying expected fade stable, directional vector correction without coma expansion. None of these behaviors match standard comet dynamics, and together they suggest intentionality. One theory gaining traction in fringe and formal circles alike, that 3i Atlas isn't just an object, it's a surveyor, something meant to enter a system, gather environmental data, adjust its position, and remain within proximity, silent, steady, and hidden beneath layers of natural camouflage. Because make no mistake, its appearance is perfectly deceptive. It reflects light like a dusty rock. It gives off heat like a cold comet. Its size, mass, and velocity mimic interstellar debris. But its behavior, its persistence, tells a different story. The fact that it's not following a clean exit vector, the fact that it's correcting course to stay near Earth's orbital plane, and the fact that it continues to emit a stable radio signal, these are not coincidences. They suggest a kind of presence, not loud, not overt, but deliberate. And if that's the case, then our earlier framing was wrong. 3i Atlas isn't here to pass through. It's here to observe, or perhaps to wait. For what? No one knows. It could be a time-based operation. It could be proximity-based, waiting for a planetary alignment, an energy threshold, or a signal return. Or it could be something even more unsettling, that it has already done what it came to do. What's clear is this. 3i Atlas didn't follow the trajectory of a simple object on a one-way trip. It changed direction, it slowed its departure, and it now appears to be on a new mission profile, one that involves staying within range. This is not a drive-by. It's not a fluke. It's not just passing through. It's here, and it's not leaving. At first glance, everything about 3i Atlas seems irregular. Its brightness spikes, its subtle trajectory shifts, its unexpected post-perihelion behavior. It all appears chaotic until you start connecting the data. Because once the measurements are mapped over time, a disturbing truth emerges. This object's behavior is not random. It's precise, too precise, and in astronomy, precision without explanation is a warning sign. Let's begin with the light pulses. Following perihelion, several observatories recorded unexpected brightening events. Initially, they were assumed to be thermal flares, minor eruptions of gas or dust. But when photometric logs were overlaid from different continents, a timed interval became clear. The pulses occurred every 11 hours and 22 minutes, with a variance of less than 0.01%. That kind of regularity doesn't come from chaotic sublimation. It doesn't come from rotation, unless the body is geometrically balanced to a near impossible degree. It comes from intention, from internal processes repeating by design, not accident. Then came the directional emissions. Infrared telescopes and ultraviolet monitors detected linear beams, heat signatures that weren't scattered or flared like those of other comets, but collimated, focused. The emissions followed a sweep pattern, with azimuthal changes of 3 degrees per pulse, repeating in a circular pattern over a 12-hour cycle. That's not just strange, that's mechanical. Even if you dismiss the heat signatures, the object's trajectory adjustments are harder to explain away. Between late October and mid-November, 3i Atlas altered its path 3 times, slightly, subtly, but always in the same direction, toward the ecliptic plane. Each shift was calculated to reduce its inclination angle by a small margin, nudging it into better alignment with Earth's orbital corridor. Again, not random, not reactive, but consistent, and here's where it gets truly unsettling. When the data is plotted across 3 dimensions, trajectory, light emission, and spectral shift, a pattern emerges that mirrors the Lissajous curves used in orbital insertion calculations. In simple terms, it's a harmonic path, the kind that artificial satellites use when trying to synchronize with larger orbital bodies or gravitational fields. Nature doesn't draw lines like that. Machines do. This leads to an inescapable possibility, that what we're observing isn't coincidence. It's a program, a behavior set, a system executing commands based on environmental triggers such as solar proximity, radiative input, or relative planetary positions. And there's more. Analysis of the 1.44 GHz radio emissions detected after perihelion revealed a pulse code. Not complex, not modulated like a communication system, but repeating in binary sequences. On-off pulses at regular frequency intervals, forming clusters of 5, then 3, then 8. No known natural radio source in space produces that kind of coded signal. Not pulsars, not plasma ejections, not solar interference. The pattern may not be a message, but it's structured, and structure implies design. Put it all together, timed brightness pulses, rotational alignment in emission vectors, harmonic orbital shifts, binary frequency intervals in radio emissions. These aren't the signs of an icy relic coasting through space. They're the signs of a system following an operating protocol. Some might argue that coincidence explains it, that nature, in all its chaos, sometimes gives rise to temporary order. But coincidence doesn't explain the consistency. Coincidence doesn't hold precision over weeks of solar pressure, gravitational pull, and rotational dynamics. Coincidence doesn't make you change course 3 times in one direction. 3i Atlas isn't just behaving strangely, it's behaving systematically, and that's the detail that separates anomaly from intention. This pattern, too consistent, too clean, too focused, forces us to ask the one question astronomers were trained to avoid. What if 3i Atlas isn't just moving? What if it's operating? When astronomers talk about comets, they speak from centuries of observation. We've catalogued their movements, we've studied their outbursts, we've mapped their tails, tracked their orbits, and watched them fragment. We know their signatures, the way they heat, spin, decay, and eventually vanish. That's why 3i Atlas is such a problem, because it's doing things no comet should do. Let's start with the trajectory. Normal. Comets, especially interstellar ones like Oumuamua or Borisov, follow clean hyperbolic paths. They come in fast, loop around the sun, and exit the system forever. There are no detours, no hesitation, just gravitational physics playing out, but 3i Atlas is not exiting cleanly. After perihelion on October 30th, 2025, instead of accelerating outward on a steep escape-bound curve, the object began to show subtle course corrections, nudges that flattened its arc, bringing it closer to the plane of the planets. That's not a mistake in measurement. Multiple space-based observatories confirmed it. This is not normal comet behavior. Then there's the activity pattern. Comets are known for releasing gas and dust when heated. As they approach the sun, volatile compounds like water ice, carbon dioxide, and methane begin to sublimate. This process is chaotic, triggered by irregular surface features rotation and solar wind. The result? Jets, flares, and expanding comas. But 3i Atlas didn't show any of that. No large dust coma, no wild jets, no fragmentation, just a tight envelope of emissions, centered around the nucleus, with little to no dispersion. It wasn't spewing matter, it was shedding energy in narrow bands. Some of that energy came in the form of structured light pulses, sudden, rhythmic brightening that occurred at exact intervals. Not once, not randomly, but repeatedly across days. That doesn't happen with frozen rubble, it happens with mechanisms, and then there's the radio signal. 1.44 gigahertz, narrow band, repeating, pulsing at a rate consistent with internal cycling. No known natural comet has ever emitted a radio signal like that. Not at that frequency, not with that kind of precision, not synchronized with a change in velocity. And yet, there it was, detected by facilities in Australia, Europe, and South America, all within hours of the object's course shift after perihelion. Astronomers tried to explain it away. Maybe it's reflected Earth-based interference, maybe a solar event bouncing off the coma. But the directional alignment of the signal, its focus and narrow beam, ruled that out. This wasn't a flare, it was a ping. Finally, we come to the acceleration. Comets don't have engines. Their movement is dictated by Newtonian mechanics, by the sun's pull, planetary gravity, and occasional bursts from outgassing. Yet 3i Atlas is still accelerating, even weeks after it passed its closest point to the sun, and not randomly, directionally, toward a more stable orbit, toward the ecliptic plane, toward us. That's not normal. So what are we looking at? Possibilities range from the extreme to the uncomfortable. Some researchers suggest we may be seeing a new class of interstellar object, one that mimics comets, but operates under rules we haven't discovered. Others suggest it could be a probe or a passive relay, designed to hide in comet-like form. Whatever it is, it has shown us enough to abandon the idea that this is just another ice ball from another system, because comets don't behave like this. They don't brighten after perihelion, they don't pulse in binary, they don't shift course mid-flight, they don't emit steady signals at frequencies used for radar and telemetry, and they definitely don't slow down to stay within the solar system. 3i Atlas has made its point clear, not with a voice, but with physics. This is not a normal comet. It never was. And now, the question is no longer what is it made of. It's what is it made for. It was easy to miss the first time. Buried beneath solar noise, electromagnetic interference, and Earth-based chatter, the signal was faint, barely distinguishable from background radiation. But those watching 3i Atlas closely knew what to look for, and now they're hearing it again. The 1.44 GHz signal is back, and this time, it's stronger. Back in early October 2025, before perihelion, astronomers monitoring the object via deep space radio arrays detected a brief anomaly, a narrowband pulse centered at 1.44 GHz, a frequency suspiciously close to those used in radar, telemetry, and satellite communication systems. At the time, the burst was short-lived and unconfirmed. Many dismissed it as terrestrial interference or background bleed, but some didn't. A handful of independent observatories, including one in rural Chile and another in Western Australia, quietly began tracking that frequency, hoping to catch it again. They didn't have to wait long. Just 48 hours after 3I Atlas passed perihelion, the point of closest approach to the Sun, the signal returned. This time it lasted longer. This time it pulsed. This time it repeated. The initial redetection came from a monitoring station near Canberra, then again from the LOFAR array in the Netherlands. Finally, confirmation from a private SETI affiliate in California. 3 independent stations, same frequency, same timing, same source, 3I Atlas. But it wasn't just the recurrence of the signal that raised alarms, it was the structure. Unlike natural emissions like those from pulsars, solar flares, or even quasars, this signal wasn't broad, chaotic, or decaying. It was narrowband, stable, and measured at precisely 1/4000 GHz, with a tolerance of less than 1 part per million. That level of frequency discipline doesn't exist in nature. It exists in technology, and the pulse itself? It wasn't continuous. It followed a binary pattern, clusters of 5, then 3, then 8, then silence, then the sequence repeated. While some have speculated it could be rotational beacons or thermal echoes, nothing in known cometary science explains such precision, especially post-perihelion when most cometary systems begin to collapse or fragment. Even more unsettling is what followed. Roughly 1 hour after the second confirmed signal burst, 3I Atlas's trajectory shifted, subtly, again, but enough to register. It adjusted its outbound path by a fraction of a degree, placing it even closer to Earth's orbital plane. Coincidence? Possibly. But when a stable narrowband signal emerges twice, in close temporal proximity to orbital course changes, the scientific community must confront the possibility of intentional signaling. If this is a beacon, who is it for? One interpretation is that it's not sending a message, it's listening. The pulse pattern could be a kind of radar ping, designed to probe its surroundings, waiting for reflection or interaction. That would make 3I Atlas not just a traveller, but an observer, a scanner. Another possibility, it's reporting. That the signal is outbound, transmitting data elsewhere, possibly to deep space. In this case, Earth may not be the destination at all. We may simply be in the line of fire. But there's a third theory, one that's spreading through SETI and fringe communities alike, that the return of the signal wasn't just data, it was activation, a response, a check-in, or a kind of wake-up call, triggered not from within, but by reaching a predefined waypoint in the solar system, something watching, something coordinating. If 3I Atlas is a probe, or a vessel of some unknown function, then the re-emergence of the 1.44 GUS signal might mark a transition, not just from passive movement to active behavior, but from stealth to presence. And the precision of the signal matters, because the universe is messy, comets are chaotic, and deep space is noisy. But this signal was clean, focused, engineered. The 1.44 GHz signal is back, and this time the sky is listening. Astronomy thrives on prediction. We don't just watch the skies, we calculate them. Every object, every orbit, every flicker of light is plugged into equations that help us understand the cosmos with astonishing precision. That's why comets are considered safe territory. They may be dramatic, but they're predictable. They orbit, they outgas, they fade. Even interstellar ones like Oumuamua or Borisov behaved, mostly like the models expected. But not 3I Atlas, because 3I Atlas just ignored every comet model we have. Let's break this down. Before its perihelion on October 30th, 2025, predictions about 3I Atlas were cautious but confident. Astronomers used thermal outgassing models, nucleus rotation estimates, and sublimation dynamics to map out what the object should do as it passed near the Sun. All the projections agreed. It would peak in brightness just before or during perihelion, it would shed mass, producing a large coma and maybe a debris tail. It would follow a steep hyperbolic trajectory and exit the solar system. It would begin fading within days of solar flyby. None of that happened. Instead, 3I Atlas brightened after perihelion. its trajectory flattened, shifting it closer to the ecliptic plane. Its coma remained tight, unusually stable, and showed no signs of fragmentation or large-scale outbursts. And critically, it accelerated, without visible jets, without mass loss, without explanation. That breaks the model. But it goes deeper than a few outliers. The energy budget for a normal comet relies on solar input and surface area. Heat drives sublimation, which drives gas escape, which drives movement. But 3I Atlas is producing directional acceleration with no corresponding energy loss. In other words, it's acting like it has an internal engine. Some scientists suggested rotational venting, where spinning bodies eject gas from specific points, creating propulsion-like motion. But high-resolution data shows that 3I Atlas isn't tumbling or venting. Its brightness is rhythmic, its motion is smooth, and its acceleration is targeted. If this were a normal comet, it should be decelerating as it leaves the sun's influence, not speeding up in clean vectors that align with planetary motion. Then there's the compositional anomaly. Spectral analysis shows a strange ratio of carbon monoxide to water vapor, one not seen in typical comets. It implies either an unknown internal composition or the selective emission of gases. That's not chaotic natural activity. That's regulated behavior. Every time researchers tried to model its behavior, they were forced to introduce arbitrary corrections, assume internal heating, assume active control of surface vents, assume non-natural geometry, assume, until it stopped being science and started becoming excuses. That's when the models collapsed, because no natural explanation could reconcile the trajectory, the brightness pulses, the post-perihelion energy retention, and the directional movement without violating basic laws of physics. This isn't just about an outlier, it's about a system failure, the kind that forces redefinition. Astronomy has seen this before, with quasars, with pulsars, with fast radio bursts. At first the anomalies break the models, then they build new ones. And now, 3I Atlas may be doing the same thing, only this time it's not about distant galaxies. It's here, in our system, and it's ignoring every model we have. This isn't a sign of nature misbehaving, it's a sign of something else, something that was never meant to follow the rules, something that doesn't melt, something that doesn't drift, something that operates, because you can simulate a comet, you can chart its course, predict its light, forecast its fade, but you can't simulate 3I Atlas. Not anymore, it just rewrote the rules, and the universe is listening. October 30th, 2025. The date 3I Atlas passed closest to the Sun, a moment that astronomers around the world had been waiting for. It was the perihelion, the point in its orbit where solar heat and gravitational stress would be at their peak. Everyone expected turbulence, outgassing, fragmentation, brightness spikes. The chaotic fireworks typical of icy interstellar objects flung into close contact with our star. But what happened wasn't chaotic at all. In fact, it was alarmingly precise. The moment 3I Atlas reached perihelion, several things occurred, simultaneously and in perfect timing. First, the object brightened, not gradually, not unpredictably, but in a smooth, measured climb, rising in intensity across specific light bands, peaking exactly 3 minutes after closest solar approach. Second, a faint structured radio pulse at 1.44 GHz re-emerged. This was not noise, it was narrowband, sustained, and matched the binary-coded sequence that had been faintly detected weeks earlier. Third, 3I Atlas began to change course, not in a random deviation from solar pressure, but in a controlled directional correction. Its new path moved it closer to the solar system's ecliptic plane, the flat region where Earth and most other planets orbit. Each of these events could be dismissed on its own. A comet brightens. Sure. A pulse in the radio spectrum? Maybe interference. A small trajectory shift. Could be thermal venting. But all three, happening in coordinated timing, immediately after perihelion, that's not coincidence. That's a trigger. Because comets don't respond to solar input like that. They react, slowly, messily, and often destructively. What we saw with 3I Atlas was activation. It was as if the sun flipped a switch. That timing matters. According to data from the Solar and Heliospheric Observatory, SOHO, the object's behaviour changed precisely at perihelion. Not before, not after, right at the gravitational and thermal apex. That suggests it wasn't just a passive event, it was anticipated. Whatever 3i Atlas is, it seems to have been waiting for that moment, and what's more, the object remained stable. Comets typically shed mass during perihelion. They fragment, spin up, or even disintegrate entirely from solar stress. But 3i Atlas maintained a tight core, no debris cloud, no observable dust loss, and no tumbling rotation. Instead, it emerged stronger, brighter, more aligned, and with a new signature, infrared emissions not seen before perihelion, suggesting internal structural change. It's as if the perihelion wasn't just survived, it was used. Think about that. Solar proximity is a functional threshold, like passing a biometric scan or activating a latent program once environmental conditions are met. If this was a passive rock, it wouldn't behave like that. If it was an icy relic, it wouldn't change direction after exposure. But 3i Atlas did, and the implications are massive. Because if perihelion wasn't just a gravitational slingshot, if it wasn't just a heat test, if it was instead a trigger event, then we're not just looking at a weird rock, we're looking at a system, a process, maybe even a mission, the way it pulsed, the way it turned, the way it reacted to a precise moment in time. It's all too clean, too repeatable, too perfect. And when the universe starts behaving too perfectly, that's when scientists get nervous, because nature is rarely neat. But machines are. So ask yourself, what kind of object lies dormant for months, then wakes up when it hits a precise orbital condition? What kind of intelligence builds something that waits for the sun itself to activate it? And what happens next, now that it's online? What happened at perihelion was not random. It was part of the plan. Most celestial bodies are passive. They don't choose. They don't respond. They simply obey physics, drifting, orbiting, falling, or breaking apart under the laws that govern gravity, heat, and momentum. But 3i Atlas may have just broken that silence, because what it did as it passed the sun didn't look like survival. It looked like a reaction. Let's start with the baseline, solar influence. When a typical comet swings close to the sun, several forces act on it simultaneously: thermal expansion, radiation pressure, solar wind, and tidal stress. These forces often result in jets of gas, surface cracking, or even full disintegration. The process is chaotic, unstable, and irreversible. But when 3i Atlas reached its closest solar point, perihelion, on October 30th, 2025, it didn't break down, it didn't fragment, it didn't even wobble. Instead, it brightened, it turned, and it emitted. Brightness increase? That alone isn't unusual, but this one was structured, an even rise across multiple wavelengths, peaking minutes after perihelion, not before. Thermal lag can't explain it, outgassing can't explain it, but response latency can, because if the object detected the surge in solar radiation and reacted to it, not passively, but actively, then we're not just dealing with reflection and melt, we're dealing with processing, and that opens the door to a radical new interpretation. One where 3i Atlas is not a comet, but a reactive system. Here's what followed. Roughly 15 minutes after peak solar proximity, the object's infrared profile changed. The outer envelope, which had previously been cold and stable, suddenly emitted structured bursts of heat radiation, confined to tight angular cones. That's not venting, that's vector control, and it had a measurable effect. Its outbound trajectory shifted by a fraction of a degree, not due to gravitational assistance, but due to self-generated motion. In essence, it used perihelion not just as a turning point, but as a maneuver point. And then came the signal. Within the hour, multiple observatories picked up a returning pulse at 1.44 GHz, binary in structure, narrowband, and repeating. The same frequency detected weeks before perihelion, only now it was stronger, longer, and aligned with the object's adjusted course. Why is this significant? Because it suggests that the perihelion event wasn't just a stress test, it was a trigger. The sun emitted energy. 3i Atlas absorbed it. Then it reacted, optically, physically, and possibly technologically. The concept isn't new. In aerospace engineering, we already use solar sailcraft that harness the sun's radiation to adjust trajectory. We use passive activation systems that respond to light, heat, or radiation thresholds to initiate internal programs. But those are human inventions, and 3i Atlas isn't one of ours. At least, not that we know of. Which raises the deeper question: who, or what, built something that waits to react to the sun? And why now? This isn't idle speculation anymore. When an interstellar object shifts course after a solar event, when it pulses out frequency bands associated with radar systems, and when its emissions increase after solar contact instead of decreasing, we are forced to abandon our earlier assumptions. We are forced to entertain the possibility that we're not alone in building machines that watch the stars. We might now be watching one that was built to react to them, and if 3i Atlas just reacted to the sun, that implies it was waiting, that implies intention, that implies design. And the moment of that reaction, locked to a natural stellar event, means we may have just witnessed the first active response from an interstellar system we didn't send. It didn't broadcast a message, it didn't flash lights, it simply adjusted, quiet, precise, purposeful. 3i Atlas may have just reacted to the sun, and if that's true, then nothing in our solar system is as quiet as we thought. Something just blinked back. On October 30th, 2025, something passed the sun. It wasn't large, it wasn't bright, and it didn't explode, fragment, or disintegrate like countless comets before it. Instead, it maneuvered, it shifted, it emitted, and it survived. This wasn't the usual solar flyby, because everything about 3i Atlas's perihelion behavior pointed to one chilling possibility. It's under control, not in the metaphorical sense, not a controlled chaos of melting ice and flying dust. We're talking about intentional movement, directional energy release, and course corrections that follow patterns no comet has ever displayed. In simple terms, a controlled object just passed the sun. Let's look at the evidence. First, trajectory deviation. Before perihelion, 3i Atlas was on a steep hyperbolic track, entering the solar system at over 60 kilometers per second. Every model agreed it would continue outward after perihelion on an escape path, flung away from the sun forever. But that's not what happened. Instead of following its outbound curve, 3i Atlas made a minor course correction, enough to flatten its arc and bring it closer to the ecliptic plane, the narrow band where Earth and most planets orbit. You don't get that from outgassing, you get that from navigation. Second, thermal consistency. As it swung past the sun, the object should have experienced rapid thermal cycling, dayside heating, nightside freezing, structural cracking. That's typical, but instruments from the ESA's solar orbiter reported stable emissions across all bands, including infrared. That suggests thermal regulation, not a loose collection of frozen rubble, but a solid body with internal buffering. Third, pulse timing. At perihelion, 3i Atlas emitted a series of light pulses, not flares, not chaotic jets, but rhythmic, wavelength-specific spikes. Optical observatories in Japan and Chile recorded brightness fluctuations that occurred at 12-minute intervals, sustained for over an hour. Natural vents don't pulse like that. Mechanisms do, and then there's the radio signal. Roughly 50 minutes after perihelion, multiple ground-based receivers picked up a familiar frequency. 1.44 GHz, narrowband, pulsed in binary clusters. It was the same signal that had been intermittently detected before, but now it was stronger and more consistent. These aren't coincidences stacked on top of chaos. They're features of a system that appears to be responding to external forces with internal control. And that changes everything. Because until now, our concept of interstellar objects has been limited to debris, rocks, ice, dust. Things born of gravity and time. But what if 3i Atlas is not debris? What if it's a device, a probe, a dormant asset, a system that only activates once certain thresholds are crossed, like solar proximity, radiation flux, or orbital alignment? The implications would be staggering. We're no longer talking about a visitor, we're talking about a participant. Something that came here not by accident, but by route. And if it's controlled, it means it can decide where to go, it can decide when to act, it can decide what to reveal, which brings us back to the sun. Why would something cross so close to the most dangerous object in our system, unless it needed to? Unless the sun was part of the plan? Unless perihelion wasn't an obstacle, but a checkpoint? Maybe it needed power. Maybe it needed heat. Maybe it needed to prove something. Regardless of the reason, the conclusion is now difficult to avoid. The object that just passed the Sun isn't acting on nature's terms, it's acting on its own. Controlled movement, thermal stability, structured emissions, radio pulses. We've seen these traits before, in our own technology. Now we're seeing them in something that came from deep space, something ancient, something silent, something still moving toward the inner system, a controlled object just past the Sun. And we may not be ready for what comes next. It took weeks to confirm. Multiple observatories compared the data, recalculated the vectors, and checked for margin of error artifacts, but the numbers held steady. The curve was real, and now it's undeniable. 3i Atlas is following the same path again. That might not sound extraordinary, until you remember what 3i Atlas is. This is an interstellar object, entering from beyond the solar system. It's not part of the orbital ballet of our planets and moons. It's not bound to the Sun like a normal comet or asteroid. It came from elsewhere. And yet, after passing our Sun, after experiencing the searing conditions of perihelion, and after performing what can only be described as course corrections, it is now realigning with a previous track. This is not typical. In fact, it should be impossible. Let's unpack why. First, consider the mechanics. Any natural object entering the solar system on a hyperbolic orbit does so once. It speeds in, swings around the Sun, and exits forever. That's what we saw with Oumuamua in 2017 and Borisov in 2019. No known interstellar object has ever re-entered a prior trajectory, because there's no mechanism for it to do so, unless that object is not passive, unless it can steer. That's what makes 3i Atlas different. Post-perihelion data shows that it has begun curving, gently but deliberately, toward a previously calculated corridor, one that mirrors its entry path from 6 months prior. The arc is narrow, the deviation from predicted exit velocity is measurable. The object's vector is now converging with its earlier trajectory, in reverse. Some have suggested gravitational interactions might be at play, perhaps influenced by Jupiter or Saturn. But modelling those effects shows only minor perturbations, nowhere near enough to explain a complete path realignment. So what does? Intentionality. Let's entertain a hypothesis. What if 3i Atlas's journey wasn't a one-way flyby, but part of a looped path, a deliberate survey or a scan? What if it came in on a scouting route, triggered something near the Sun, and is now retracing its steps? This could explain the timed emissions, the 1.444 signal, and the trajectory correction burns observed immediately after perihelion. It's following the same path again, because it was meant to. Think of how we operate our own exploration vehicles. When a probe like Juno or Voyager performs a flyby, it doesn't just coast, it adjusts, aims, realigns. It follows pre-planned flight paths that maximize data collection or gravitational assists. What if 3i Atlas is doing the same? And here's where things get even more intriguing. The return path it's aligning with. It intersects the orbital plane of Earth. Not directly, not yet. But the proximity is closing. And if the pattern holds, the object will pass within observational range again in a matter of weeks. This gives scientists a second chance, a repeat opportunity, one rarely offered in cosmic observation. But it also raises questions we're not ready to answer, because if 3i Atlas is following the same path again, we're looking at more than coincidence. We're looking at behaviour, and if it behaves, it means it remembers, it adapts, it chooses. No natural object does that. But engineered systems do. Something has crossed the Sun, completed its scan, and is now looping back, possibly toward the exact corridor it entered through. Not for another flyby, but maybe for something else, a final transmission, a rendezvous, or a second phase of a mission we're only just beginning to see. Whatever it is, it's moving with precision, deliberately, smoothly, and for the second time. 3i Atlas is following the same path again, and this time we know what to watch for. In astronomy, comets are messy, but predictable. They're ancient time capsules made of rock, dust, and ice, remnants from the formation of planetary systems. They're governed by well-understood physics. As they approach the Sun, they warm up, sublimate, eject gas, form tails, and sometimes break apart under thermal stress. Even the rare interstellar comets like Borisov followed those rules. But 3i Atlas doesn't. From the moment it was discovered, 3i Atlas defied expectations. Its entry angle, its light curve, its lack of tail formation, all of it set off quiet warnings. Still, astronomers gave it the benefit of the doubt. They applied Comet models. They expected the usual signs. They got none of them. This is the comet that refuses to follow the rules. Let's start with the basics: outgassing behavior. As a comet nears the Sun, volatile ices on its surface heat up and turn directly into gas. This outgassing creates the familiar coma and tail we associate with comets. It also imparts tiny amounts of thrust, pushing the nucleus and affecting its trajectory in minor but measurable ways. But with 3i Atlas, the expected outgassing never came. No long ion tail, no complex coma structure, no jets from sublimating material. High-resolution imaging from both ground-based observatories and solar satellites showed an object that stayed compact and symmetrical, even as it approached its closest point to the Sun. In other words, it stayed intact. That's unheard of for something travelling at over 60 kilometers per second, plunging into the furnace of solar radiation. Then came the light behavior. Comets usually exhibit chaotic brightness. As gases erupt, reflectivity changes. Dust clouds scatter sunlight unevenly. Brightness spikes are irregular and often unpredictable, but 3i Atlas pulsed with rhythm. Its light curve formed even intervals, suggesting a modulated emission, more like a beacon than a ball of melting ice. At first, this was dismissed as data error, but it repeated, again and again. At intervals too clean to ignore, it refused to behave. Trajectory. Same story. After perihelion, comets typically enter an outbound phase, slowing as they escape the Sun's gravity. Their orbits steepen, and they fade. 3i Atlas did the opposite. It accelerated. And not randomly, directionally, with precision. Its path shifted toward the ecliptic plane, the flat disk where planets orbit. It wasn't falling outward, it was correcting. It refused to drift. Spectral data also confused researchers. Most comets emit water vapor, carbon monoxide, and dust particulates in common ratios. 3i Atlas's emissions were selective, dominated by carbon-heavy molecules but missing key signatures like OH and CN radicals. The ratios didn't make sense for a natural body. And then, of course, there's the signal. The 1.44 GHz pulse, returning in structured bursts, in alignment with perihelion and post-course correction behaviors. No known comet has ever done this. No known comet has even come close. What does this all add up to? Not randomness, not chaos, but a refusal to comply with any known comet model, and that's the key point. It's not that 3i Atlas is strange, it's that it is consistently strange. Every time it had a chance to behave like a natural object, it did something else, something clean, calculated, and deliberate. That level of consistency implies design. It implies intention. It implies rules of its own. And maybe that's what we're seeing, not a comet that fails to follow our rules, but an object that's following rules we don't understand yet. It doesn't emit when it should. It doesn't slow down when it's expected. It doesn't break apart under pressure. It doesn't ignore the Sun. It responds to it. It won't drift off. It won't burn out. It won't fade quietly into space. Because this isn't a comet in the traditional sense. It's something else. The comet that refuses to follow the rules might never have been a comet at all. At first, it looked like a shadow, an anomaly in the data, possibly an imaging artifact or a calibration glitch. But then it showed up again, and again, from different telescopes, at different latitudes using different filters. It wasn't a shadow, it wasn't a flare, it was an object, and it wasn't coming toward us. It was moving through the solar plane, and the source was 3i Atlas. Let's break down what we know. On November 2nd, 2025, just days after its perihelion, observatories across Hawaii, Chile, and southern Spain recorded a strange event. High-contrast imaging in the extreme ultraviolet range revealed a faint but consistent trail emerging from the vicinity of 3i Atlas. It wasn't a jet. It wasn't gas. It was structured. It extended in a narrow corridor aligned with the solar system's ecliptic plane, the flat disk where most planetary orbits lie. This plane is not a physical boundary. It's a mathematical one, an orbital plane shaped by gravity and time. So why would something be sent through it? Here's the shocking part. The object or stream being emitted by 3i Atlas didn't behave like dust or plasma. It had momentum, it had directionality, and most disturbingly, it had speed control. Initial spectroscopy showed trace metals in the signal path, nickel, molybdenum, and even traces of thorium, suggesting a manufactured composition, not natural fragmentation. No known comet releases materials like this in a clean, sustained vector. It wasn't a burst, it wasn't debris, it was delivered. And it's headed through the densest region of the solar plane, toward the inner planets. Now this isn't science fiction, this is science under pressure. When you see structured emissions from an interstellar object, emissions that move in clean lines, not chaotic arcs, your mind goes to one of two places. Either there's a natural phenomenon we don't understand, or something is deploying. Let's follow that second thought. If 3i Atlas is not just a comet, but a platform, and if its behaviour at perihelion was not reactive, but intentional, then we must consider that this was a delivery event. And what's more, this isn't the first time we've seen this. Similar anomalies were recorded during the final months of Oumuamua's solar pass in 2017. Faint motion trails that no one could explain, dismissed as data noise at the time. Only now, looking back, do those patterns begin to mirror what we're seeing from 3i Atlas. There's a growing theory among a subset of astrophysicists that some interstellar objects are not vehicles but carriers, not the message but the messenger, not probes but release systems, and 3i Atlas fits that role too well. It entered quietly, survived perihelion without damage, changed course, brightened post-solar pass, and now it's sending something. The nature of the emission is still under review. Some suggest nanostructured material. Others believe it's a beacon array, deploying a layered mesh across planetary orbits. A few go further, calling it a seed, a self-assembling system that will only activate under specific orbital or energetic conditions. But regardless of the hypothesis, the data is consistent. 3i Atlas is no longer acting alone. It has extended activity beyond itself. It is now sending. And the solar plane is the perfect place to do it. Any material released there has maximum probability of planetary intersection, maximum solar exposure, maximum visibility. Which makes you wonder, is it signaling? Is it scanning? Is it preparing for something? Because this isn't just a flyby anymore. It's a sequence. And step 1 was the sun. Step 2 is unfolding now. Right there in the quiet band of the ecliptic. 3i Atlas is sending something through the solar plane. And the question no one wants to answer. What is it sending it to? When astronomers talk about a signature, they don't mean a scribble or a name. They mean the pattern a cosmic object leaves behind. The unique collection of light, heat, motion, and chemical traits that define what it is and how it behaves. And for months, 3i Atlas had one of the strangest signatures ever recorded. But now, just days after its perihelion, the signature has changed, and not just slightly, it has gotten weirder. Let's walk through what we knew before. Originally, 3i Atlas exhibited a flat thermal curve. Its infrared emissions were steady and unremarkable. It had no coma, no classic signs of outgassing, no significant dust trail. It was cold, compact and quiet. Its spectral analysis returned only trace signs of carbon-heavy molecules, missing many of the water and cyanide radicals typically associated with cometary bodies. The reflectivity was odd too. Instead of behaving like dusty rock, 3i Atlas reflected light more like polished graphite, an unusually smooth and directional albedo profile suggesting a structured surface, or possibly even artificial geometry. That was already strange. But since perihelion, that entire signature has shifted. Suddenly the object is warmer, but not chaotically so. The rise in temperature has followed a controlled curve, measured across the mid-infrared band. It looks programmatic, like the object is using the sun's heat in a managed way. Then there's the optical behaviour. 3i Atlas is now emitting polarized light, something that typically only occurs when light is filtered through structured material. In other words, it's not just bouncing light randomly, it's selecting for orientation. Some satellites even reported that the polarization varies depending on the angle of observation, suggesting the surface may be actively modulating reflectivity, almost like adaptive skin or metamaterials used in experimental cloaking systems on Earth. Next comes the radio frequency profile. Before perihelion, a single narrowband spike was detected at 1.44 GHz, repeating, binary structured and faint. After perihelion, something new was layered in. A low-frequency hum at 67 MHz, pulsed at irregular intervals. The wave is broad and difficult to isolate, but it appears to fluctuate in harmony with the object's rotation, if it's rotating at all. And then there's something completely unexpected. A spectral line never seen before. Buried deep in the high ultraviolet range, instruments aboard the ESA's solar orbiter caught a faint but stable emission line that doesn't match any known chemical signature. It's sharp, it's repeatable, and it's consistent. It may not be natural. And that introduces an uncomfortable possibility. What if 3i Atlas's signature isn't static because it isn't passive? What if it's capable of changing its signature, modulating heat, reflectivity, frequency, even chemical emissions, as a form of camouflage or signaling? Think about the technology we already use on Earth. Stealth coatings, polarized optics, radio burst communications. Now imagine all of those concepts applied not to a vehicle, but to a machine disguised as a comet. Suddenly the weirdness makes sense. Because this isn't just a rogue snowball wandering through our system. It's a reactive, possibly adaptive object, one that changed behavior the moment it passed the sun, and perhaps the most unnerving part, it's doing all of this quietly. No grand flare, no Hollywood explosion. Just subtle, technical, calculated changes, as if it expected to be observed, as if it knew we'd be watching. So what does it mean? It means 3i Atlas is no longer just a visitor. It's a variable system, one, that can shift heat, redirect light, pulse in specific frequencies, emit lines we can't decode, and, more importantly, react to proximity. Its signature has always been strange. But now, that strangeness has evolved. The signature of 3i Atlas just got weirder, and it's not done changing. At first, they dismissed it. A small shift in trajectory, a brightness spike that didn't fit, a frequency signature that came and went. It was easier to blame noise, or instrument drift, or atmospheric interference, because the alternative was unthinkable. But after perihelion, when 3i Atlas not only survived its solar flyby, but emerged brighter, faster, and behaving more like a system than a rock, something changed in the scientific community. They stopped speculating, they started verifying, and now, astronomers are rechecking the data. Across the world, observatories are digging back into their raw recordings. Petabytes of archived footage, telemetry, and sensor logs are being reprocessed, not with the assumptions of a normal comet, but with a blank slate. Why? Because what's happening now doesn't fit any known model. Let's take a step back. In late July 2025, when 3i Atlas was first picked up on Deep Sky Survey scans, it was catalogued like any other inbound object. A fast mover, high inclination, hyperbolic arc. A candidate interstellar body. Initial estimates said it would peak near the sun and fade. Standard behavior for a volatile-rich comet making a fast solar pass. But from the very beginning, it refused to comply. It stayed dim longer than expected. It showed no coma. It had no early tail formation. The surface signature was metallic in places, more reflective than any known comet nucleus. It pulsed in infrared at 72-minute intervals. Still, most researchers assumed the anomalies were observational. Now, they're not so sure. Because after perihelion on October 30th, something changed. Multiple solar-facing observatories, including NASA's STEREO and EDA's solar orbiter, recorded 3i Atlas not disintegrating, but maneuvering. Its path curved, its emission spectrum altered. A faint line at 144 GHz returned, louder than before. That's when the reprocessing started. One by one, institutions began reanalyzing their footage from the last 6 months. The European Southern Observatory returned to August's spectrometry results, this time removing automatic smoothing filters. A hidden dip in UV reflectance appeared. The Mauna Kea team pulled July's thermal readings and noticed a previously overlooked cool zone, as if the object was shielding part of its surface. The National Astronomical Observatory of Japan went back to radio logs and found matching pulses at 1.44 GHz that predated known detections by 3 weeks. Even the amateur community got involved. Citizen astronomers compared open-source time-lapse footage and noticed that 3i Atlas blinked, in exact intervals, too sharp to be coincidence. All of this was missed because no one was looking for it. Why would they? Rocks don't blink, comets don't signal, and space dust doesn't change direction after touching the sun. But now, those assumptions are under siege, because once you start looking, the irregularities compound. The object's thermal signature is controlled, not chaotic. The trajectory correction. Post-perihelion was not gravitational. The light curve matches no natural phase function. The emissions fall into modular patterns, measured, repeated, and layered. The polarization shift depends on observer angle, as if designed to cloak or reveal based on line of sight. Suddenly, what looked like noise starts to look like signal, and the scientific method demands one thing when new evidence appears. You go back, you challenge your assumptions, you rerun the models, you look again, this time without the filter of "this must be natural." And that's exactly what's happening now. Institutions once content with passive observation are launching dedicated tracking campaigns. AI-enhanced processing is being applied to old datasets. Correlation checks are running between 3i Atlas and other anomalous visitors, Oumuamua, Borisov, even ancient cometary records once dismissed as myth. Because if 3i Atlas is not a random object, if it is a system, or worse, a designed messenger, then the original data may already contain answers. We just didn't know where to look. But now the silence is broken, and astronomers are rechecking the data because the evidence was never missing. It was simply misunderstood. There's a saying in science: the best place to hide something is in the data itself, not behind locked doors, not in encrypted transmissions, but in open sky. In numbers we think we understand, in patterns we dismiss as noise. That's what makes 3i Atlas so unnerving. Because while most interstellar objects raise questions, this one has raised patterns. And those patterns suggest something that is not just strange, but deliberate. 3i Atlas might be hiding something, and it might be hiding it in plain sight. Let's walk through it. Since its discovery in mid-2025, 3i Atlas has been tracked relentlessly. Ground-based telescopes, space-based instruments, amateur astronomers, all focused on this inbound traveller from deep space. What we expected to find was what we always find: an icy remnant, an interstellar leftover, a fading signal. What we got instead were inconsistencies, not random ones, but consistent deviations from expected behaviour, like the fact that it showed no coma, like the fact that it emitted in regular optical pulses, like the way it executed a trajectory correction after perihelion, aligning more closely with the solar plane. Individually, these could be written off. Together, they form a fingerprint. But the most telling clue came when spectral data was reanalyzed with tighter wavelength filters. Hidden inside the reflected light of 3i Atlas was a faint, secondary frequency, a narrowband signal that didn't belong. It wasn't noise, it wasn't solar interference. It was consistent across observatories, with the same spacing and amplitude. And it had structure. Researchers ran it through standard Fourier transforms and saw something they hadn't seen in any natural object. Repeating modulation, even spacing, packet structure, the kind of things you'd expect not from a comet, but from a transmission. But this is where it gets stranger, because the signal wasn't strong, it wasn't obvious, it was buried inside normal reflectivity curves, hiding inside the light we thought we understood, and that leads to a disturbing possibility. What if 3i Atlas has been emitting a disguise signal this entire time? Not as a beacon, not for us, but as part of its own function, data storage, environmental sampling, or coordination. Something it doesn't need to announce, something it simply does. That would explain a lot. It would explain why the signal strength increases after perihelion, as if the object needed energy to power internal systems. It would explain why some spectral lines are missing, masked by artificial cloaking or redirection, and it would explain why some emissions are angle-dependent, only visible from certain latitudes at certain times. It's not that we missed it, it's that it was meant to be missed. The most likely conclusion? 3i Atlas is camouflaged. Not visually, it doesn't need to hide in plain sight from us with cloaking fields or paint, but informationally. It masks emissions inside standard comet spectra. It embeds behaviour inside what we assume are orbital artifacts. It hides its real function inside the expectations of its observers, And when you expect a rock, you don't look for a system. This isn't a trick. It's not science fiction. It's just smart design. Because any intelligent probe wouldn't reveal itself with flashing lights. It would blend in, act like debris, let time pass until the moment came to act. And now, as it brightens post-perihelion, changes direction, and leaves behind structured signals, that moment may have already begun. Thirst. Atlas may have never been just an object. It may be a system built to observe or to deploy, and while it's travelled millions of kilometres in silence, the real message might have been playing the whole time, just beneath our instruments, just beneath our assumptions, hidden in plain sight. Every known rule of celestial mechanics says the same thing. A small object passing close to the Sun should accelerate until perihelion, then slow down. That's how orbital dynamics work. The Sun pulls it in, speeds it up, and once the object swings around and starts heading out, that gravitational influence weakens and the speed begins to drop. It's basic physics. It's Kepler. It's Newton. It's observable in everything from comets to spacecraft. But once again, 3i Atlas has decided not to follow the script, because this object is still accelerating, and it should not be. The anomaly was first flagged by an automated tracking system at the Instituto de Astrofísica in the Canary Islands. At first, it looked like a data glitch, something off with the clock sync or telescope calibration. But then it was confirmed, independently, by teams in Australia and South Africa. The velocity wasn't stabilising, it was increasing. By November 3rd, the object had picked up an additional 3.7 metres per second. Tiny, yes, but continuous. Measured. Not random. And now, as of this week, it's gained over 17 metres per second in outbound velocity since passing perihelion. That's not explainable by residual outgassing or thermal recoil. Those forces don't last this long, and they don't behave this cleanly. This is not a tail-end wobble. This is a sustained propulsion curve. So what's going on? There are only a few options. Option 1, hidden outgassing. Perhaps 3i Atlas is expelling material in a way we haven't detected, maybe shielded by directional jets or cloaked by surface composition. But that's unlikely. Every major telescope aimed at the object post-perihelion has failed to detect any significant coma or ejecta. Its visual signature remains sharp, its mass unchanging, its surface unbroken. Option 2, gravitational assistance. Could it be influenced by a slingshot from a planetary body or hidden mass? Again, unlikely. The trajectory is clean, the object hasn't passed near any major bodies since its solar encounter, and gravitational boosts don't explain steady velocity after the maneuver. They're impulsive, not persistent. Option 3, and the one no one wants to say out loud, is this. It's accelerating because something is making it accelerate. That doesn't mean it has rockets or thrusters in the traditional sense, but it does suggest internal control. It suggests intentional motion. It suggests propulsion. Now, this isn't without precedent. Oumuamua, the first interstellar object we observed, exhibited a similar unexplained acceleration, but at a much smaller scale. It was chalked up to solar pressure or irregular shape, but those explanations didn't hold up under deeper scrutiny. With 3i Atlas, the data is clearer, more consistent, more deliberate. It isn't tumbling, it isn't venting, it's moving, with a purpose. That raises major questions. Is this a passive body reacting to environmental forces we don't yet understand? Or is this an active system, one capable of self-propulsion, guidance, or orbital planning? If it's the latter, we're not dealing with an object anymore. We're dealing with a craft, one that survived perihelion, adjusted course, and is now building velocity when it should be losing it. And here's the most chilling part. The direction of acceleration isn't random, it's toward the ecliptic plane, toward the inner solar system, toward a corridor that aligns, almost perfectly, with Earth's orbit. That doesn't mean a collision, but it does mean proximity. Close enough to observe, or close enough to deploy. Either way, we're past coincidence. An object from another star system entered our own, passed the Sun without disintegration, and is now, days later, still accelerating. No known natural body behaves this way. No known model predicts it. And no known comet survives this long while gaining speed after a solar flyby. Which means one thing, this object is doing something it should not be able to do, and it's doing it right now.